Share screen, there's 2 buttons. All right, here we go. Thank you for that. All good, right? Okay. You could just mute your mic, please. Thanks. Getting some background noise. JavaScript conditionals. That's what we're going to get into. If you're going to be a programmer, you're going to end up knowing how to do some type of conditional programming. Else, if-else statements, else-if, logical expressions and operators, ternary operators, and then switch statements. So ternary is probably not saying it right, but it's a newer kind of. You know what happens is one language will get something really, really nice like C# or Java. And then once the adoption rate's really high and everyone gets used to it and says, I wish I had this if it only had that. So then they add it to the spec. So ternary operators have, sometimes you catch yourself again, is this work in there? And you have to look at the docs. So it's a cool, sometimes called the Elvis operator. We'll get into that. So what is conditional programming? So conditional programming is conditional statements that check whether a programmer specified a Boolean condition is true or false. So many times you need to check the whether or not your condition is valid or not. So they make it possible to test a variable against a value, compare a value with another variable, make the program act in the way if one condition is met and another is not. For instance, if there was, so at my workplace, we are doing a big push because we need to launch express pickup. So you need to have a way to select stores, and you need that. So there's a way we consider it a flag, and this is like a big picture. It could be true or false. Is that feature on or is it off? If it's on, then the UI will show those components, and data gets routed in a different way. If it's off, that experience, they call it experience, is the old way, right? And there's all sorts of metrics around that, but that would be a very, very important kind of flag. But you can have very small flags. Maybe it's just very like, and I'm calling them flags, but they're Booleans, true, false. Anything from, is this component visible, or is this person an administrator? Things like that. Sometimes you need to check, and it gets complicated sometimes when you have multiple flags going on, but that's a Boolean condition. Sometimes it's called a flag in programming. So they make this conditional programming, make the program very powerful. You'll be able to use it for a variety of purposes, from creating a simple calculator to controlling robots, right? If you have an electrical engineering background, or something about electrical, they have all these resonate back to gates, like and, or, nor, NAND. So basically the positive and negative, each of those, and it's kind of like circuit paths, and in a way we kind of program like a path, right? So a program has conditional statements. So a program that has conditional statements is called a conditional program, and the process is also known as conditional programming. If you have a very flat program that just does something like we've been working with the last couple, all our labs, if you notice, there's not really much logic there. It's just, you just render whatever is in the browser. But applications get very, very, very complicated when you really start breaking things down. Something like a checkout or a credit card processing, or some type of it depends on the business logic. If it was financial, it gets very convoluted and very complex. If it's something very simple as a site that has a joke engine or something like that, but even still there'll be some little bit of circuit flow chart you could draw here. So here's a flow chart, very, very high level. This is what we would use sometimes you may need to draw these things out. So flow charts used while designing and documenting simple processes or programs.
Mike, where do you get the logic from?
In your head, or
does somebody give this to you, or do you just make it up?
Okay, so when you, good question. When you are, okay, every job I've worked on where I'm at a company, there is usually a business analyst, somebody who knows how to translate the requirement in a way down to that you can make logical decisions on. They work at a high level. When it comes to the technical implementation of things, then it's in your head. Then you really, because then you're dealing with the technicalities of it. But when you're at the high level, the requirements come from if some business person who can draft up requirements. And there's different styles of that, but that's really where it comes from. Sometimes you have a technical person who's business related, who knows technical, so he can fill the gap between how this information is interpreted down or flows down to developers. Because I don't know anything about well, I know a lot now, but I don't know a lot. I didn't at the time know a lot about financial software, and then I worked for a financial company. And there's so many rules and regulations, and I would get a document like 60 pages long, and I would have to go through it all and how this screen would work, if they have this license or that license, right? You can go and you can transfer. I forget the screens look like. Transfer a GIC or make some kind of transaction on a GIC, RSP. RSP, all these things, like, all these investments, the knowledge they would train you a little bit in some background, but really the functional requirements come in a document. Sometimes you talk about it every day at your stand-ups, you're communicating down some of this requirements, but and then you take it in your head and you try to make it work for the piece you're working on. So yeah, it's many parts to that machine that kind of runs. But sometimes you're on your own. Sometimes you're just building a site freelance, and then you have to kind of talk to the, say there's a construction office, somebody hires you to do some kind of inventory management system. You got to talk to the guy. You have to be the business person. You have to be the project manager, and that's freelance, and that's a little difficult because there's no in-between person there. It's just you to flush out the details. And then you have to try to take what you have, the feedback you got, and try to create a picture in your head that hopefully you're right, because you only have one person to deal with, right? So, but anyhow, there's yes. So when you're on your own, you have to come up with the requirements yourself. When you're in a company, you have many people who are helping you with this type of thing, so that when you get down to programming, you know exactly what you're doing, so you don't have to worry about the business part of it. All right, so this is a flow chart. Yeah, that was a context to that. I went on a rant there, but so these help you visualize what's going on, thereby help you understand the process, perhaps find flaws, bottlenecks, and other less obvious features within it. I must say, when I'm programming, I don't have time to do a flow chart. I don't draw one out. However, in the requirements, for instance, in the financial software, somebody who has given me the documents, the tech documents, has spent the time to really do flow charts if it's a very big kind of step through or something like that, right? Like, you add something to your cart, you need to check out. If you don't have a credit card, go back to step number 2, and you kind of need all of that flushed out. But this would be a simple case here. You have a bulb, a light bulb, it doesn't work. Is the switch on? So if you've never seen this before, the diamonds are decision blocks. These usually are the ones that have a yes or no. These decision blocks will break out into 2 paths. So you have an action, which is or a statement, the bulb doesn't work. And then you have a question or a decision to make. Okay, is the switch on? Because if it's on, I'm going to go this route, and I'm going to output, or I'm going to say the switch on the bulb. That's my course of action. I follow that path. Otherwise, the decision or the result is that no, the switch is not on. So then I need to do another decision, and I have to inspect that. Is the bulb burnt out or not. If the bulb is burnt out, yes, then I need to do something else. I need to check the connection. Otherwise, I need to replace the bulb. So this flowchart could be, it doesn't just apply to programming, obviously. You could have this in engineering or any type of logical, process you may need to do in business. And sometimes BAs, when I say BA, business analyst, or other related technical people on the business side will draw these out if it's very, very complex. But in your head, know that you can sit there and draw, think your program through. Sometimes I just think it in my head, I'll take a break and I'll go for a ride, and then sometimes I'll solve things in my head and I'll just say like, okay, I need to try this. But if you're a visual person and you need to visualize it, then drawing out is a good thing. Sometimes I just talk to myself. That works. If else statements. So we have this concept here. So if you could look back at those blocks, you could actually think, okay, each one of those decision blocks is an if else. If yes, go that path. If no, then continue on to the next. And you could see there could be another if block there. So if else statements allow you to execute certain pieces of code based on a condition or set of conditions being met. It's very powerful because and helpful because it allows you to choose which piece of code you want to run or execute based on the result of this expression. So it's a very small example here, but we could test an expression in here and it'll flow. Now remember, if you're new to programming, we need to open up parentheses and we need to close it. And when we're getting into JavaScript now, we have these brackets, right? These are parentheses. I forget what they're called. Mustaches. That's what they call them. Handlebars. These handlebars, parentheses, you need to close them. If you open and close them, you open one, you need to close. Same as when you're writing with tags, but this gets really finicky now when you have a browser compiler because it will let you know. It will fail if you don't close these. You will get messages in your console. Right. So we talked about if else statements. So our first look, if we look at this, probably most common use is if else, if else or if else statements. These conditions use some form of conditional to determine what step to take next. So we usually have this. We have a condition and then we have an action. So, and here's a very simple one. So we don't have anything to test. We're just saying that it's true. By default, it's true. And it's going to evaluate when the compiler runs against that, it's going to evaluate that and just say the statement was true. In the same way, we could also do the negative there if we wanted to do that. Quickly have an example there. All right, so here's a very simple piece of code here. By the way, there are things called, I think they're called REPL playgrounds. So they're these things that you can use. They're out there for JavaScript, any language, right? You can actually go there without a compiler, without a page, and you can just start writing some code in some of these. Some are better than others, to be honest. But so how's the, you could simply just start writing here. So I could write something and say, I could write something if true, console log. This is true, right? And then I can run this, and then it'll say this is true, and then it'll give this undefined. JavaScript's weird, it'll give this sometimes. But we can actually, in this window, we can practice some of our coding without having to deal with the saving in Visual Studio and running in the browser. We just click run here, and we can test out some code. So these are called playgrounds. They're actually quite useful if you need to quickly run some code. If you don't want to deal with the other dependencies. So here's a quick one. It just says, here's a script. Here we have our tag. It's not really formatted very well, but you know what I'm saying? It should be a little indented a little bit after a while. When you're coding, you'd appreciate this on your eye. I don't like it when I can't. It's all jumbled up. In fact, I don't really like that, right? We kind of said that should be in the head tag. So let's put that in the head tag. right? Head tag, and I'm messing with their solution, but let's see if that goes. So we put our script tag in the head tag. Obviously, we could also extract it into a file if it starts causing a problem for us. So it's going to run this function we haven't got into. There's another built-in object is a date object, and on the date object there has a bunch of attributes or properties, methods on it. So this one says new date, get the hours. Is the hours less than 18? And then we're getting into something here where we're dealing with the browser here. So we haven't really learned this, but you can actually, in JavaScript, modify pieces of those HTML tree. You can select it, and then you can change the content of it. So I could change the content of something if I wanted to. What that basically says is, display good day if the hour is less than 1800 hours. And what it's going to do is it's going to select this. Now we haven't covered this, but I'm just explaining it to you. By ID, get element by ID is demo in the document, which is the web document, and it's going to set the inner HTML, which is this portion here, and it's going to set it. So let's console log maybe, or let's console log this and see if we can what the hours are right now. What time zone this is running in. Let's do this. Let's see if in my console log, my developer tools, if this will show up. In my dev tools, did it like what I said? Now remember, I don't know if you've gone through this, but in your console log, in your console, there are these other there's ways of filtering your messages down. At the top, it'll say 5 messages, but you can see, I don't know what's going on here. I don't want to see that error. And there's a bunch of other warnings here that I don't understand what's going on with that. So I can either click user messages, I can look at the error itself, which I didn't break that, so I don't want to worry about that. Or I can look at the info, and usually info is our console log there. Our console log was 18. That was the outputs here. So yes, you can filter this. Sometimes you just want to go to info if you want to get rid of, if you want to look at the errors, fine. If you want to look at the errors, good. Go ahead. If you're debugging, but if you just want to look at your console log message, this is what it is here. So we know it's 18. So if we say, all right, let's say if it's less than 20, my expectation is that this would change. But let's see. It didn't change. So it says it's still 18. Okay, I'm sorry. How about we just say true? Let's see. If true, will that work? If true. It didn't work. So it didn't like that. For whatever reason, it didn't grab that HTML message, and it didn't like that. Why didn't it like that? But at least let's see that this is going to output true here, true result. At least we know that we're not crazy by running this console log. So we are crazy, I guess. It didn't like this execute block here for whatever reason. There's something in there that it didn't like. So that's strange. That's very strange. Maybe there's an error itself. Let's comment this out. Let's get rid of this completely. Console log that. Yes, so there's something wrong with that element that we haven't learned about. So there's something up with that. So that's what the deal was with that. So let's just console log this and forget about this UI here. True result. All right. So there. All right. So that was that. So there's something wrong with that selector. But the point was, we have a value here, and if you are at home and this is very convoluted to you, I would actually use what we learned in the last class. And I don't know if that's a better view here. Maybe not. What I would do is I would use variables, because I don't like that. I don't like how it looks, because I'm repeating myself twice. I have a computation going on the date and getting the hours twice, and I don't really like that. Plus, there's a lot of parentheses and things like that going on, and I don't, it kind of drives me crazy. So I would actually rather have this hours, current hours, and I would rather do this, so I can actually use a variable multiple times. So then it's clear to me what I'm testing for. So now I can tell in my condition that I'm testing that the hours, you could actually name it current hours, whatever makes sense to you, but Now I know this logical conditional is that if it is less than 20 hours, log, console log the true result. Yes, go ahead.
Hi, Michael.
Yes.
Okay, so what does the new date means? The new keyword?
Mm-hmm. Well, we haven't dealt with objects yet, and we haven't dealt with objects, so that's internal. Those keywords are, well, when we get into object-oriented programming and when we get into that kind of work, there's a concept of new, because now we're creating, and we haven't learned this yet, but we will. It's going beyond this. There's a concept of objects, and when you create a new object, you need to give the keyword new, and it creates a new instance of that object. But we are not there yet. But just know there's built-in functions, right? Because if you didn't do this on this function here, you most likely would get an error probably that there was something wrong here that it didn't like. But these are built-in objects, and we will learn this eventually here. But the main point is here, it doesn't matter if we extract this out and it's a variable like that. This is what we know. We learned in our last class strings, booleans, numbers, some of those other primitive types. We haven't learned objects yet, and we haven't learned arrays yet, and we will. But really, at the end of the day, this is what we're after here. We're after a simple test here that we can check the hours as less than 20, and therefore it will output our result. But this is a very simple block, and we're going to get into more logical blocks. So that's a very, very easy condition. If you hard code to true, then it's going to fall into that. Otherwise, it'll go to, it'll either, if you have no other case, it'll just fall out of this block, this expression, and it will continue on and execute to the next thing. However, there is a concept of if else. So now you can test both ends of that decision block, the yes or no, the true or false, and you can go often those paths, those circuit paths, if you were an electrical engineer. So the value inside the if statement is always converted to true or false, depending on the value of the code inside the if statement is run, or the code inside the else statements run, not both. So it's those two decisions. Based on those two paths, it's going to execute or not. Code inside the if and code inside the else, surrounded by those curly braces. Ugh, how many times did I get that wrong? Curly braces. Call them handlebars. In fact, there's a whole scripting language called handlebars out there that they just call these handlebars. Sometimes they call them mustaches. Curly braces, man. To separate the conditions, so we need to make sure we keep track of our braces, our curly braces. Otherwise, we can get into some issues here. So we have this. Otherwise, if you don't end your one of those blocks, it's just going to think that it's just going to keep looking for the next matching curly brace, and then in that case, the compiler kind of gets all out of whack, right? Because it'll keep executing till it finds it, and it'll actually throw lots of errors. So here's another else if statement. What to wear tomorrow? All depends. We're all at home, so I don't think it matters, right? Is it going to snow? So yes or no. So if yes, it's going to snow. Should wear a coat. No. Is it going to rain? Yes. Wear a jacket. No. Wear what you have on. Just go. Come as you are. So in some situations, two conditionals are not enough. So you don't. So this represents a simple if else. But then we need to continue on into this the no path. But also, I mean, we're just showing this extra if else statement. But you could also have it run through this path. There could be a whole bunch of other conditionals. I mean, if you're drawing a flow chart, this flow chart definitely doesn't need to end here. We could have many more of these decision blocks throughout our path and continue on with this code. We might, say, okay, is it, sorry, is it, wear a coat, do I need boots? I don't know, yes or no, go along that way, go along that path. So you're trying to decide what to wear tomorrow. If it is going to snow, then you'll wear a coat. If it's not going to snow, and it's going to rain, you need a test for that. You're gonna wanna wear a jacket. And if it's not going to rain or snow, then you're just gonna have to wear what you have on. So that's another way of handling some other logical paths. So this is what it looks like. Now we have 3 conditions to worry about our test for. So here's our variable up top, which if you run it and refresh it, you got to keep changing the text, which can be very monotonous. And when we learn some more reusability, how to reuse code, you're going to figure out that you can create code that is not so linear. This code's very linear, just run once, and you have to refresh your browser, and then change the weather for the other cases. So here, it's going to look at this text here, sunny. Obviously, the first condition is going to fail because, and if you notice, they're using the triple equals. Remember, we talked about equality and inequality and being very strict. So it's not going to try to convert on you. It's just going to say, okay, is this string truly a string? I'm not going to convert it. Whatever value it is, whether it be a Boolean or a number, it's going to take it as it is and compare it to snow. It's going to fail in this case, so it's going to skip this whole thing. The next block, decision block, else if, is this, again, strict equality. Is sunny equal to rain? No. So then it's going to fall to the default block, which is an else. And that else block will just say wear what you have on. In the same way, if we were to change this to snow, obviously the first condition would be met, and then it'll execute stop. It will not execute out of this block. It'll just console log, and it'll come exit out of the code. We change this to rain, it'll skip the first one. It'll be evaluate this expression will evaluate to false, and then it will go to the next one. This will evaluate to true, so then therefore it'll just console log, bring a jacket, and then execute out or break out of this conditional. So as you can tell, you're kind of getting a little bit more, we're getting bigger into some of our coding here. But we could have something that looks like this. So here's a piece of code. So there is some new syntax here that you haven't seen. That's a little bit of a preview of things to come. So you know they're out there. There is a concept in ES6 called constant, and there is a syntax called let. Just assume they're vars right now, VARs. Really, what constant means really is this. It's a really nice thing with ES6. This will not change. Nobody can overwrite this anymore. I'm saying that this is a constant variable, and nobody should be changing this in my code, which is great. It's a way of locking things down. And then let is a different thing in itself that we'll talk about at some point. So this quickly defines my variables up top, saying I have a maximum discount, a minimum discount. So these are going to be used in all my calculations. And then I'm going to have a variable called amount. First test case is 570 greater to, so we have an arithmetic operator here. Is this amount greater or equal to 500? So it is greater than, and then that's true. It'll evaluate. So then therefore it'll output your discount is, and then it'll calculate, calculate 15% times 570, give that percentage in the total. Then it does another calculation in there. Right, and if you notice, and if you're coding like this, you can tell here that you have a parenthesis here that closes out one, then I have a second one, and that closes out here, and then I have another one here to match it, closes out there. So, sometimes well, definitely the editor will let you know, but I kind of like to extract a lot of that out, because if I'm if I'm coding in here, let me just, I'll do something similar. I have a, what do we have? Something like, let's just say max equals 100. min equals 0. You know, if I'm going to have a variable that is you know, amount equals to whatever, 500, 550, you know, as I am typing, you can see, right, log, it'll have one parentheses. So I could say something, I could actually say total is, we don't know about template literals yet, so we're not going to talk about those, but we could do something. This is a way of concatenating, by the way. There's a better way to do it when we learn ES6, but concatenating, you can use plus and it'll actually concatenate a space for us, and then concatenate a calculation for us and convert it to a string, because it'll convert it. All right, I could do something like amount, you know, parentheses around it so that it evaluates. I could do amount times, and if you notice, it kind of will match up for me. If I don't have it matched, it's going to give me an error when I run this. So you need, as you type your parentheses, you'll see it kind of hover over. It'll kind of give a little bit of a bevel. And I'm sure there's probably some extension that'll actually highlight your matching code completely, your parentheses, in a better way. Like this, maybe I'll look for that. But there's a way of, so now you're saying that you're actually matching up those. And it's not very, you can see those little squares there, right? But I mean, maybe if you're starting out, you might want something that highlights really well. And I'm sure there's an extension here that we could probably find for that. Yeah, so if I did this times the max, you know, I don't know, some calculation plus min, you know, anyways, as you can tell, you're already kind of looking at this saying, I don't get all this, you know, this, I've only done 2 here. You can have as many, you could have so many of them, but for me, I like to actually move these out into their own variables, right? Amount times max plus min. I can console log that. I could actually inspect it a little bit. I can see what that value is, and then I don't need to like, it makes my output a lot cleaner, because then I can kind of tell what I'm doing there, because now I look at that and I can tell what I'm outputting, and I don't, not only can I check the value here before it gets outputted, I actually know what I'm outputting, which makes a lot of sense for clarity of code. You know, and then if I did my conditional, I said, okay, if calculated value is greater than the max, then I do something else, like console log calc is greater. Otherwise, maybe I want to, okay, if I just say else, then I'm handling the negative of that, and I'm saying calc is less. However, that's only 2 cases here. So if I wanted to add another case to this, I could actually say else if, and then I have my parentheses to have another expression in there. Calc is equal to, I don't know, calc is equal to max. I'll use strict equality. All right, so then I could output that. Console log calc is equal. Right. So we have a little bit of a script here. We have a little programming, little script that does just some calculation. It goes through 3 steps. At the base level, it's 1 level deep, meaning it doesn't go any deeper than this. So it is somewhat clean. Yeah, I don't know how much we could refactor that unless we knew some other ways of organizing code. So that's what an if and else block would look like. All right, so let's try to get to at least, let's try to get to logical expressions and operators at least. Let's try to get there. All right. All right, as you can tell here, so we have this calculation here. Here it gets a little bit more complicated. This is a discount determiner, if else. Now, if you notice up here, require. So we don't need to really know what require is. Actually, right now, so this script, require, is actually a Node.js script. that runs JavaScript. Require comes from Node.js. So this is kind of a preview of a Node.js script. But we don't need to worry about now. Pretend this is in the browser. So now we have a couple more discounts. Now we have a max, a middle, and a min. And we're going to take some input from the user, and then we're going to capture this amount. And remember, you're not going to be worrying about what this is. We're really worrying about the if block, if else block. If amount is greater than 500 and it's true, we're going to go through this calculation. If it is greater than 250, it'll go through another calculation. Otherwise, it's just going to do the minimum calculation. There. So 3 statements. Not too bad. All right. So now this gets even crazier. Look how crazy this is. It's hurting my eyes. So this is something there. You could have nested multi-conditional if else's. So you can tell here now we have a little bit more complex stuff going on here. And to me, this is a bit messy. Like I would rather extract some of this out and make it more readable. This is not readable to me. I can kind of tell what's going on, but you know what's going on here. So we have a condition up here that says, okay, is the amount greater than 500? And it has 5 items. Okay, the user spent at least $500 and purchased more than 5 items, so that when this evaluates to true, give this calculation out. Otherwise, if the amount is by default, it'll be less than 500 and it'll be less than 5 items. So then we're checking. All right, okay, did the user spend at least $250? Then go inside of this nested block, right? And then we check again. Is the items greater than 10? If the user purchased at least 10 items, then we give him a special discount. Otherwise, he purchased less and we give him the middle discount, right? Otherwise, now we have to go back out of that nested if statement. It's not, user did not spend $500 and 5 items. It's not greater than 250. So otherwise it must be less than 250. So we go down here, the user spent less than 250. He gets a minimum discount and the calculation for his total. So this is a lot of nested logic here, right? And if it hurts your eyes, it hurts my eyes. I don't like to look at this kind of stuff if I can help it, really. If I was doing this, I would refactor in a cleaner way to kind of explain what's happening here. All right, so that is that. But if you notice, we didn't really go over some of these things, and we're like, what this double ampersand is here. It's the first time we saw this. So we're going to talk about that. So logical expressions and operators.
Quick question here. When we have these multiple if statements here, can we put all this? Can we put the outcomes into a table? So we just refer back to variables that are already in a table.
Yeah, I mean, to be honest with you, I would when we learn tomorrow's class on functions, there's a way of encapsulating all of these things so that you can reuse your code. Because right now we're copy paste, copy paste, copy paste, and it looks, this is not reusable. Because if I add another if else, I got to copy paste all this again. So yes, to your point, instead of tables, there's other containers that we can use and that we can clean this up quite a bit, so we're not duplicating our work. In much the same way as styles, in much the same way as, well, mostly styles, right? You know, when we're dealing with CSS, why not build one global style for buttons instead of keep having to, do the same type of attributes on every single button? In the same way, we can reduce our code, make it more logical, and make it more descriptive by extracting it out in a different way. But for this, I'm just showing you this because this is how it can look. It looks like spaghetti, right? Spaghetti code. That's a terminology where it's hard on the eyes, and you don't know what's going on inside of it. So logical expressions and operators. Yeah, it took a little while to go through this, but this is, if it's new to you, this is a different way of thinking for sure. This, I'm sure in blockchain you have concepts of, flow charts and things like that, but This is this is coding the logic. So logical expressions and operators. So you may have seen it already and not understood what it was, but here's the logic. Here's a logical expression used to represent a person's weekend plans. So you have a person who's not busy because he's in lockdown, right? And the weather is nice, and you do a check, but you're testing for two conditions now. Instead of doing nested if statements, you're checking, because you could easily do a nested if statement for this, but you're doing a double operation here. So you are checking if he's not busy and the weather is nice. So if it's, and this is an and operator, then we're going to go to the park while the weather is good. So this double ampersand symbol, very important, you'll see it a lot, is the logical and operator. And I should show you a circuit design. How I learned this when I was learning this portion of it, they showed us in university. It was electrical circuits and the gates. They called AND gate, OR gate, NOR, and NAND. And we did some circuit building based on those. Same kind of thing. But you'll see this double symbols, and it's used to combine two logical expressions into one bigger one. You may combine many things, and it gets messy. You could have a very big condition. If both smaller expressions are true, so this one evaluates the true, and this one evaluates the true, then the entire evaluation is the true. If either one of them is false, then the whole logical expression is false. Another way to think about the AND operator's placing is literally in the code reads, if the person is not busy and the weather is nice, then go to the park. Right. So what that is saying is, well, let's look at that example here. So we said person is not busy. Weather is what? Nice, I don't know, summer. It's nice. Right. And we're just saying if the person is not busy and weather equals nice, then we console log go to the park, right? Else we could add an else condition, and then we could say, okay, it'll stay inside. Stay inside. But you see there that if you did not know about these logical operators, then you might have a situation where you would have to have another if statement in here to say, is the weather equal to nice, right? If you didn't have that way of combining, like you would have to nest it then, right? So then it gets a little bit more like convoluted. What's going on here? You know, okay, I'm not busy, but then I'm checking the weather is nice, and I have a nested statement, and you know, that's two layers deep, depth of two. I forget what they call the complexity level. That's what they call it. So that's level 2 complexity, but we don't need that. It's more clear to have it in this way where we don't need that nested if statement entirely. We're testing the outer block right there. Right. Oh, sorry. In that vein, what would happen was it would evaluate to true. In this case, it'll evaluate to true. So therefore, true and true are true. You know, true and true evaluates to true, right? So then therefore, this whole expression would be true. That's how it would evaluate. And then it would fall into this. Now, if the condition was different, the condition was the weather is, suppose this was cold. This first condition would evaluate to true. This comparison would evaluate to false. So true and false, you know, it's like positive and negative will actually negate to negative. So true and false will be false. So then therefore this will fail. This will not fail, or just, it will fall to this one here, stay inside. At the same time, if this was a false and false, that would be false. And, you know, again, if it was a false and a true, it would be false, right? So there's a whole grid on this, but that's what it would evaluate down to. Right on. So logical operators and expressions, we will get to truthy values. Let's go to truthy and falsy, because I think I have a slide now that's a duplicate. Yes. All right, so logical expressions. Logical expressions are similar to mathematical expressions, except their logic expressions evaluate to either true or false. So 11 is not equal to 2. That is true. So we've already seen logical expressions when you write comparisons. So we've already done some comparisons like greater than equal to, the strict equality. A comparison is just a logical expression. So similar to mathematics, we use plus, minus, times, division, percentage. Those are the expressions in math. We haven't gone over some of those. Pretty straightforward, but there's the logical expressions that you need to know as well. And in JavaScript, they usually come in twos. So there's double ands, double straight lines, and then there's a weird exclamation mark in there in the syntax that you can use all these combinations to make more complex expressions than the one we just showed you. So you can really, you know, you can really create some interesting cases in this way. All right, so this is the operator table. So these can be used in conjunction with Boolean true or false to create complex logical expressions. So we combine two Booleans together with a logical operator. You can create that logical expression. So as we said here, when we're combining them, it'll actually combine down. It doesn't matter if you have, it doesn't really matter if you have a very complex one, especially if they're all true. If there's one false in there, it's going to negate everything. So in order for that expression to truly fall into the go to the park, all of the logical expressions have to evaluate true. That's the only way that this guy will actually get to go outside. So any false in any of these places will actually cause this whole thing to fail. So you might as well just have false for everything. It'll eventually, in that scenario, it'll all evaluate to false. At the end of the day, it's going to be true or false. No matter how many conditions are in there, it'll evaluate down, and this conditional inside of the expression will just flow to the next path. All right, so yes, we said combining them, you create a logical expression that returns a Boolean value. So this is the table. So we have the logical and, so value 1 and double ampersand, value 2 returns true if both values evaluate to true. Now I showed you a little bit deeper where all of them have to be true. This one is the logical or, so it's two lines, and it can be true or false. So returns true if either value 1 or value 2 or even both evaluate to true. So in that scenario there, you could now, it's not as strict because you could actually, if you had this condition, by the way, I'm doing Control Z to roll back my changes here. Right, so if we're back here, you could actually put in place of the and, make it less restrictive, and have an or. So now we're saying, if the person is not busy or the weather is nice, then let them go to the park. So now it's more chance, there's more opportunity for this expression to be true. Either one of them can be true, whether, you know, it's true. Once it hits a true, it'll stop evaluating, to be honest. Once it hits as true, it will automatically execute out. It doesn't need to look at this one really. It'll probably evaluate it, but it doesn't really matter if it's true or true. As soon as it hits that first flag, it knows it's going to this block. At the same time, it doesn't matter if it's false. Sorry, it doesn't matter if we have as many falses as we want in this statement. If there's a true in there, it'll basically, that's what the evaluation will be, true. And that's or. So and or, and there's combinations of and ors you can do. And then there's another one which is called not logical, and a logical not, so a not expression. So this will return the opposite of the value. So it'll flip the switch in that it would evaluate this to be false, because it's flipping it. That will actually flip it, right? So that'd be false. At the same time, that would be true. Why would you need that? Because why would you need that? Okay. Well, firstly, you could also do, so you might have a flag, as we said, is I don't know, weather widget or control. Okay, is date picker. Suppose you had a date picker on the screen. Is it visible? Is it visible? It's true, but we want the opposite condition of that. We want it to say, okay, if the date picker is not visible, right? We want to test the fact that it's not visible. Maybe we need to hide some things. Maybe we need some code in here that says, okay, do not show the date picker. And then we need to maybe do some logic to, I don't know, clear the dates, something else, what have you. Maybe this is not even, maybe it's a module. Maybe it's something like, okay, even better. Is this person an administrator? Is admin? Okay, well, if he's not the administrator, then we are going to give him, in our code base somewhere here, we're going to give him limited access in the application, right? And we need to handle that. So there's reasons why you would check the negation of something like that. If he's not the administrator, then I need to lock the application down globally. So that would be a reason why you would want to check. You don't want to check the fact that he is the administrator. You want to check the fact that he is not, because maybe there's some permissions or security around the fact that he doesn't have a role, or he's operating in a guest mode or something like that. So that's why you would use negation. Stay with me, please. We have 4 or 5 slides. We'll take a break after that. Stay with me. Logical operators, right? So we got that. So we tried to talk about this already in a way, but this is a table. This is kind of a table of, it's called a truth table. Brings me back. Truth tables are used, and if it's new to you, maybe you might want to have this truth table in front of you. I don't know. They're used to represent the result of all the possible combinations of inputs in the logical expression. A represents the Boolean value on the left side, and B represents the Boolean value on the right side. These truth tables are helpful visualizing the different outcomes for all the logical expressions. You don't have to notice anything particular about it. Otherwise, you can just refer back. So double ampersand for and, as we already said. It's only true here when both are true. So true, A is true and B is true. We have true every other combination. If there's a false in there, that fails. Or is a lot more flexible there. You see the opposite in a way. If there's a true anywhere in there, then it's always true, except the fact where everything needs to be false, therefore it's false. So there's 2 opposites there, right? And an or. How you combine these is where the logic really, where even to this day I sit there and I may have to deal with an if statement. I really have to break it down because I may have 5 cases, or I may, try to make it somewhat intuitive, but sometimes you sit there and you're like, okay, I need this to evaluate true first, and I need to handle a couple other combinations, and then you can mix and match the negator one. It gets really interesting. So logical short circuiting. So that's kind of what we're getting at here. So in the end, if there's a false anywhere, it just short circuits to false. If there's a false on either side of it, it'll just evaluate to false. Same with the or. If there's a true, it just evaluates right to true. It just skips the whole B condition. It short circuits, you get that result. So these are the two cases where it would always be false, right? If there's a true in the first evaluation for the or, if there's a false in the evaluation for the and. So it's called logical short circuiting. So if in those both two tables there are scenario where regardless of B and A is enough to satisfy the condition, right? We said if it's A right away, sorry, if it's true or false right away, if it's false for N, we just exit out. If it's true, we also, that's all we need. So if you look at A and B, if A is false, then regardless of the value of B, the total expression will always evaluate to false because both A and B must be true in order for the entire expression to be true, which is covering this scenario here at the top. In the same way, for or, the bottom scenario where all is false will equal false, or all needs to be true for it to be true. Sorry. All A and B need to be false for it to be false. Otherwise, if there's a true anywhere in each one of the variables, then it automatically becomes true. The behavior is called short circuiting because it describes the event when the later argument and the logical expression are not considered because the first argument already satisfies the condition. All right. So here is an interesting one. So here's a couple logical expressions here. If we were to chain them, because that's what it's called, chaining. When we start chaining them, you're gonna see how better it works. So we have a string, hello world, hello, and world and JavaScript. So this is how it evaluates. So again, JavaScript's really weird in the sense that it'll evaluate a number and it'll evaluate it. It'll do some type of comparison and say, okay, and it'll switch the value to truthy or falsy on you, which is a little strange. But in the first input, all three strings are equal to true, and they're evaluated left to right, returning the last value. So true, true, true. In the second output, all four equate to true, and the first instance of true is returned. So this one is returned true. So this is really quirkiness of JavaScript, but basically it's saying this one satisfies true, so it exits out right away. This would evaluate the true, 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 so then therefore the last true is evaluated out to true. Yes, very strange indeed. Short Circuit. If you don't remember, that was a movie. This was the first Wall-E. His name was Johnny Five, I believe. Anyways, it looks like Wall-E, but depending on, it's actually called Short Circuit. So depending on the scenario, you may come across a time where you need to run a complex function with your conditional or possibly even more complex conditionals, which I already showed you. It gets very complicated. If you understand short circuiting, you can see that any combination of logical ands, starting with the value that is the most likely to be false, could prevent excess calculations. So really, if you run into a false at some point in an and statement, if you have a very heavy, so if this was a bunch of heavier calculations, is, I don't know, is secure, I don't know, is whatever, I don't know. Calculate something, calculate all records greater than 0, right? Greater than 100. So you have 1 million records in the database. If he's not the administrator, then I don't need to go through and calculate all these 1 million records in the database, right? So this will just skip out and it'll short circuit. Therefore, this case will never run at all if this is evaluated to false. It'll just skip out. And then this whole case will be skipped, which is good because we don't want to run 1 million records, especially in an if block, but short circuiting will prevent those other longer running computations from running. All right, 7:15. Let's get a half-hour break and then come back at 7:45. Go through the rest of this, get done, do the lab, but let's try to get through this lecture part. So let's come back in about a half hour, okay, guys? All right, I'll stop sharing. Thank you.